What is up everyone and welcome back to my channel. If you are aware about the BodyCam game, you will know its photorealistic graphics and amazing mechanics. So in today's video we are going to recreate the first person camera from this game in Unreal Engine 5. So we are going to create the camera look movement, not the actual locomotion but how the camera is moving using the first person template, and we'll also use the post-processed materials to have this kind of effect. So without further ado, let's get started. In the past months, I had created something similar to BodyCam even before the game got released. It really looked nice, but after the game got released, I got to know about what other things that we could add to make these first-person camera look even much better. So yeah, let's get started. Alright, so here's the first person template. I have already implemented the mechanics and the effects. So let me just hit play and show that to you. So as you can see, we have this post process material. So I'll break it down. So first let's have a look. So here's when we grab the grunt. We have this realistic kind of looking movement when I look, and when I move we have the camera shake as well. So if you compare this with the BodyCam game, you can find most of the things similar, which they have implemented as well. So let's break it down what all things that I have implemented to get this kind of effect. So if I move drastically, you will find that the vignette is moving and the gun is also moving somewhat like this. So here I have opened up the first person default template. So let's start with opening the first person character blueprint. So here's the character blueprint. Let me bring the window right here. First we'll do the setup of the camera. So we need to add a spring arm and we'll attach the first person camera to the spring arm. So just add spring arm. Right, so spring arm, and just drag and drop this right over here. Now we just need to reset its location, this and this, camera and the spring arm. Right, so first the spring arm location, I have set this to 15. Then others I have set it to default. Then we have the first person camera. Here we'll set Z to 60. Alright, and at the first person mesh, this will set this to -25, and this location will set to -150. Alright, let me hit compile and let's check this. I'll hit play. So somewhat like this, which is the basic setup. Now let's start with adding a camera shake over here. So currently we do not have any camera shake. You can find the screen is just stable. We just have this animation running. So go to content and create a folder of BodyCam. Here let's create a new folder of blueprints, and here we create a new blueprint class and search for camera shake base. So camera shake base class, open up. So we'll rename this camera shake idle pp. So save it, and we'll need camera shake walk and run. Walk, and another one will be run. Okay, so first we need to set the root shake pattern. So here you can set, we have few default ones: composite camera shake pattern, Perlin noise. So the mostly used is the Perlin noise. So I'll just open this up. So set this and open this up. So we can have camera shake in the location, rotation, FOV. So we won't change the FOV here, and the timing over here. So in the XYZ pitch, roll, yaw, we can add the amplitude and the frequency. So I have already tested these values, so I'll just enter them down over here. Compile, say let's set the walk. Now I'll set the run camera shake. So once you have all the camera shake pattern, so you can just play with the values just how you want to set the location of the camera shake, or you want to rotate the camera shake. So yeah, now let us implement the camera shake patterns. So I'll go to the event graph and I'll get the event tick. I'll run it through a sequence, as we are going to implement multiple steps. Okay, so first we can create a new function. We'll call this as camera shake, right? And I'll bring this here, connect it. Okay, let's open the camera shake. So to have the effect of camera shaking when we are moving, we need to get the character movement so that we can calculate the velocity from the character movement. And with the help of the velocity, we will be using whether we want to add the camera shake idle, or we want to switch to camera shake walk or run. Alright, so first we'll get the camera movement from here. We get the velocity right at the bottom, and from the velocity we will get the length of the velocity. So vector length, this one right here, and from here, so if we just print and check what we are getting over here. So let me hit compile and let's run. So it's basically the speed at any direction that we are running, right? So I'm currently using keyboard and mouse, so it will just drastically go from 0 to 600. But if you are using a controller, you can control the actual speed by using the analog stick, right? Alright, so let's open up first person character blueprint, and inside the camera shake, let's start implementing this. So if the vector length is less than equals to 0, so less than equals to 100 actually, if it is less than equals to 100, using branch, what we can do is we can return the idle state. So we'll get player controller, and from here we're going to start camera shake, this one right here. Here we can set idle. Alright, now if this is greater than 500, right, so greater than equals to 400 or 500, anything you can choose from. So same, from here it falls, branch, compare this. I just duplicate this right here. So if this is true, we're going to set this to run, right? Because the maximum value of running we have is 600. Right, so connect this to the target, and if not that, you can just switch to walking basically. Alright, let's test this out. Hit compile, save. So we could try to visualize over here. So currently it is setting it to running, then walking, and then idle, and the rotation as well, just to show you that how it is looking in the camera. So you can see there's a lot much amplitude over here, right? So I'll just set it to the values which I came up with. Alright, so this is how you can implement the basic camera shake on your first person character. And when you switch from idle to running, we have a camera shake, and when you are switching back to idle from running, we have a subtle camera shake. Alright, so now we will start implementing the next step. Next we'll be implementing the inverse rotation of the mesh. So we'll add a new function. We'll just call this inverse rotation effect. So here basically what we are going to do is reverse the rotation of the mesh in whatever direction our mouse is moving basically, or our camera is moving. So we'll get the first person camera, and from here we'll get relative rotation, this one, and we're going to use invert rotator. Right click and split, and we're going to get our first person mesh from here, and then we are going to set relative rotation, this one right here, split structure, and we're not going to add any roll, basically just going to work with pitch and yaw. So the pitch we are going to divide. Let me showcase this to you while directly connecting this over here, and here set the use spawn control rotation. We're going to set this to true, right? We also need to set the camera lag. So open up the spring arm and enable camera rotation lag, and set this, by default it is set to 10. Now let me hit play and you'll see the effect. What you see now, what's happening is the gun is getting outside of the frame, right? You just need to here divide this and this as well. It's basically the strength by which the invert rotation will be added. So this pitch I set to 8 and this I set to 4. Now hit compile, save, and now you'll get this effect. So you rotate, even if you rotate fast, the gun is not moving out of the frame. You can also clamp this, but I think this is much better, right? So we have this realistic kind of effect. Alright, so we'll move on to the next step. So for that we will need to implement the post-process materials. We'll set that to our camera. So let's start by creating a folder inside here. Call this as post-process materials, and we'll start by creating a fisheye material. So m underscore fisheye, and it's a post-process material. Open this up and we'll set this as a post-process material. We don't need this cast ray trace shadows. Okay, so I have already created a video about the post-process effects in this video, adding first-person camera with body cam effects with motion matching. So inside this video I have explained how you can create a vignette post-process material and also the fisheye post-process material. Here I've explained the entire process, like how it is getting calculated and stuff. Right, so you can watch this video. So here I just quickly create. And there you go, we'll have the fisheye effect. Right, so let's apply this to our first person character. So let me just close all of these. So open up the first person camera and here just search for post process material. Post material, this one. Inside the rendering features, add an array element, choose the asset reference. Here you can search for your fisheye effect, hit compile, save it, and let's see this in action. So let me just close all of this. Right, so here we have the post process material applied. So now we have this fisheye effect and with our inverse rotation as well. We can increase the FOV even more, maybe 120 would be better. So from here, right. So this looks nice. F11 to full screen directly. So next we'll add the vignette effect. Now let's create post-process material for vignette. So vignette post-process. So open this up. So material domain post-process, we don't need this. Again, for this vignette as well, I have created this video where I'm explaining how you can create vignette post-process material, so you can just refer this. Alright, so again we need screen position. We'll divide this by 2. And this is the radius, so if it is 0 it is fully covered, 0.1, 0.5, so yeah, I'll set this to 0.3, So this is the vignette effect. So let us add this to a post-process material. So add another array element, asset reference, this one right here. Hit compile, save. Right, so here we have the vignette post-process material and it's working fine. Right, so even if I do full screen using F11, there you go. So now what we are going to add to actually increase the immersiveness and add a little bit touch of reality over here, what the BodyCam game is actually doing. So currently you can see our screen is shaking when we are moving, so that is fine. We have this inverse rotation of light, we have the fisheye effect, and also the vignette. But you will find that the vignette is not moving when we are moving the mouse, so it is not that much immersive. So we are going to add vignette offset, and we can also add vignette shake just to give support to the camera shake, right? So that is what we are going to add. So first we are going to create a material parameter collection. So just search over here, material parameter collection for vignette. Right, so let's open this up. Here we're going to add two vector parameters. One will be for our vignette offset and another one will be for vignette shake. Right, let's save this, and what we can do is we can convert this and collapse this to we can collapse these nodes. So right click, we can collapse this and we can rename this as vignette effect, something like this, right? And let's open up the first person character blueprint, and here we're going to add another function. So inverse vignette effect or offset. Okay, so whatever we did over here in the inverse rotation effect, we're just going to replicate this. So I'm just going to copy this part, so copy this inside here, just paste, and here we're going to set vector parameter value. So this one right here, we'll select our vignette parameter name is the offset, right click and split. Right, so to set the parameters values, of course we need to use this. So let's open up the post process material and open the vignette effect. So we're going to add the effect right over here. So right click and get your parameter collection. So collection parameter, and this one is for the offset. We're going to break two components. So instead of this, so we'll divide this basically by 2. So this we will add, and this we will add something so that we can get back to the center, right? And what we can do is make float 2, and we can attach this over here. Right. Here we can set 0.25, and if I set 0.25, yep, somewhat like this. So here we have established the connection. Let's get back over here. So what if we, so basically we need to set the R and G, which is A and B over here, R and G, this one and this one, which will be the sphere mask B, right? So basically it will move. So this is if I again add a value over here. If I set this to 0, it is moving right over here. If I set this to 0.5, it is moving right over here. So if you want to add the shaking effect or the offset, so this is what we are going to change basically, because this is our center position, right? So 0.25, and this is the center of here. So the values, these values will be changed. So the A and this one, right, this value we will get from here. Okay, so from the first person camera, the pitch, let's just connect this directly. And yeah, don't forget to set your function right here, call it, so inverse vignette effect, call this function. Right, let's see what happens. So if I try to move up and down my mouse, my vignette offset is moving left and right. If I do left and right, currently nothing is actually happening. But if I move up and down, it is moving left and right. So that means this value will go over here, right? And so when I use pitch again, so when I'm doing up and down, so yep, it is going up and down, but I want it inverse. So what I'll do is divide by -8 basically. So 8 is just the amplitude by which it is moving, right? So yeah, this is what we need. Same if we connect this to here, and so if I move left, it should go right. If I move right, it should go left. So yeah, that seems fine. And now we just have to increase this, so divide this by, so the value which I came up with is -500 here and 800 or 1000 over here. Alright, so save it and hit play. So if I move, you will find the amplitude, it is actually shaking. If I move up and down, we can decrease this, so maybe -300. Let me hit play. So yeah, somewhat like this. So we have the effect, inverse rotation effect on our mesh, and the gun is also a child of the mesh, so it is being applied on that, and the vignette as well. So let me hit F11. So there you go. If I move left, the vignette is also moving. If I move up and down, the vignette is also, there's inverse effect to it. So the camera shake for the vignette, so for that, first we will need the action value X and the action value Y from the move component, basically WASD, right? Those values. So from this, we'll promote this to a variable. We'll call this right movement axis, and let's set this right here. And this one will also promote forward moving axis. Alright, and let's create a new function over here, call this vignette shake effect. Before I forget, let me just add this over here. Okay, so inside the vignette shake effect, so again we'll calculate using first we'll calculate whether our character is moving or not. So get a character movement, so get velocity right at the bottom, and from here get vector length, this one. If this is greater than 0, of course we are moving, that means, right? If this is true, then we are going to branch here. If this is true, we are going to set vector parameter, this one, and vignette shake. Alright, so how we will calculate whether it is shaking or how much amplitude we want to shake. So when we are moving forward and backward, we want it to shake in forward axis, basically somewhat like this, and when we are moving left and right, it should shake somewhat like this, right? So let us also set the vignette shake in a post process material. So here again we need collection parameter for the vignette shake. So now this will be divided into 4 because we need both of the effects simultaneously, right? So just going to copy paste this, and there will be only one make float, right? So we're going to add this and this, and basically x and x, y and y. So going to add this x and this x. Let me duplicate, and we're going to add this y and this y, somewhat like this. Okay, and then we're going to make float, and we'll divide this by 2, this by 2, everything by 2 basically, and this by 2. So here we are in the center position, right? So this is our center position. Let me actually get this. All right, so we have the vignette effect right here. Let's get back. So how we will calculate is we'll get our movement axis, so the right movement and the forward movement both. Going to use f interp to constant, and here going to choose random float in range. So this, what this will return, so if I print this, so it will basically return 1 and 0 or -1 basically, and this as well. Okay, if I use W and S, forward movement will have 1. If I use right movement, I'll get value in A and D. Okay, so the minimum value here is -1, max this, duplicate this, this as well, so -1 and 1, and we need get world delta seconds for the delta time right here. And the interpolation speed, we can set this to 10. Yep. And then we're just going to divide this by, here I'll divide this by 100, put it right here, and this I'll put right here, just how we divided right over here, similar to that, just the value I came up with so that it looks better. Alright, so I don't think there's any other thing needed to set here. Let me hit play and let's see what happens. So, you know, when we move, the vignette is actually moving. Actually, when I'm moving left and right, it is moving. So if I'm moving right, it is moving to the right. If I'm moving left, it is moving to the left. So we need to inverse the, actually over here in our event graph, right axis we need to inverse. So we can negate float right here, and then we can give this inversed value. Alright, so now if I hit play, if I move forward, you can see how the vignette is moving as well. If I move left and right, it is also moving. And to make it shake more, you can just experiment with the values over here. If I set this to 10, we will be able to get that shaking effect actually. Let's see how it is shaking. Right, so that's the, you can say, amplitude. So maybe 80 if we set. You can also try to interpret again to 0 after it is set. This is what I came up with, and it actually looks decent. So in our vignette post-process material, we already have our vignette effect, which is getting calculated, and it also have the offset and the shake, right? So we can add another material for this, another layer basically. So what we can do is right click, and we can collapse this to black vignette effect, somewhat like this, right? And what we can do is just duplicate this basically, and we can give it some other color if we need, right? Like other vignette effect. Okay, and what we can do is blend both of these. So we can lerp, linear interpolate between both of them. For example, this one, instead of black, I will give kind of reddish color, right? Okay, and here I can set, so we'll need another parameter over here. This radius I can set 0.2 and hardness I can set 0.5. Okay, so this color I have set this like reddish type of color. So we can reuse this. We connect this over here. So of course 1 means if it will give weightage to this red vignette. If it is 0, it will give weightage to black vignette. 0.5 in the middle. So for this as well, we can use a sphere mask. Connect this to alpha, and here we need the screen position again, and here we need vignette position, and this we can set the main mask radius. So right click, convert to parameter, mask radius, and the hardness, we just set the hardness to 1 over here. Okay, so here we need A and B. We can just directly choose from vignette effect. So copy this vignette effect, and inside here we will need this and this, both of them. So just delete this, and the output, I'm going to add another output. So this will be screen position, and this will be vignette position. Okay, and I'll just pass this over here. So I'll hit save. We need to attach this, so screen position and vignette position. Let's save everything. So now you will be able to see both the red vignette and the black vignette together basically. Of using a color, we'll add chromatic aberration over here. Let me get back here. So over here I'll get texture coordinate first. So texture coordinate, add the intensity of all of them. So this one, move to a parameter, red offset, this one promote to a parameter, blue offset, and put this inside scene texture, and from here we're just going to mask red color basically. So component mask, just the red color, duplicate this. Here we will just mask blue color, and we can make float to here and pass. So gonna convert float 3 to float 2. So let's just give another one over here. So this one we can make G, so green offset. So let me create another one. Let's give these some value. So 0.05 minus 0.05. This one you can give 0.01, somewhat like this, and we'll convert this to float 3. So RGB, like anything will do. Let's pass it. So you will find this effect over here, right? And if we want this to the edges, so here we can choose the radius. If it is 0, it will also affect the center, right? If you want to see how this looks like, now it is the effect is added to the entire screen, and you can see the shift is actually a lot. You can see RGB, you can control the offset. Yeah, this offset, maybe 0.05 minus 0.05 and 0.08, somewhat like this. You can see it is little bit shifted, which is what we needed. Let's save this. So of course, if the radius is set to 0, that means when I play, the entire screen will have the chromatic aberration effect. So you can give it a radius. So if I give this radius 0.25, right, 0.25, somewhat like this, so the effect will be just in the edges of the screen. So what we can do is promote this to a parameter, chromatic radius, and the hardness. So right click, hardness you can set to 1, 0.5, and radius you can set to 0.2 or 0.25. You can see here in the preview mode, if it is 0, you can find this edge as well have that effect. If it is 0.2, it is now in the outside. So 0.25 or 0.2, somewhat like this should be fine. So hit save. Also you can collapse this to this node chromatic RGB. I just collapsed this, and yeah, so this is how you can have all the effect. Alt P. Now you'll find just at the edges we have that effect, so that player's main focus is at the center, right? So this is how you can create all these effects, and you can have this body cam realistic effect using and inspired by the BodyCam game, which is pretty interesting. I'll create a separate video on how you can implement this using motion matching, and we'll also have a video on new gameplay camera system. Let me give you a quick review of this material. So we have the black vignette effect, where we have the color, and we are using the vignette effect. Inside all the vignette effect, we have the vignette offset and the shake calculated. Alright, and we have separate radius and the hardness for the vignettes, right? So next we have the chromatic vignette effect that we created just now. Inside this, instead of color, we are adding chromatic calculations over here. Okay, basically we are just shifting all the colors just a bit, and here we have masking of that, Then the vignette effect of the chromatic effect, we have the radius and the hardness for that. And at the end we are looping from this to this using the sphere mask and the position, which is just the center and the vignette position, right? And we have the main mask radius, so this, and we have the calculations for the vignette shake, inverse rotation, inverse vignette, and we have just added all of those right over here in the event tick. And finally all the post process effect are applied to the first person camera, 2 of them. You can create Mateiral instance and you can just add both of them over here. Right, so if I right click, create Mateiral instance, this one and this one as well, we'll be able to change these parameters that we just now created, right, for this and for this, the FishEye instance, all of these. So yeah, let me close this and we can have a look at this. We can play it in the Pi editor window. You can have a look at the chromatic effect just at the edges only, inspired from the BodyCam game. So yeah, this is how you can come up with this effect, and I think it really looks nice. Let me know if you are interested in this project. I will be creating a Patreon page and posting this project over there. So thanks a lot for your support. Let me know what other tutorials would you like me to create. Stay tuned for more.